Hello folks, I wanted to post a video out there on why someone should buy Celestron 8SE, right? So this is the Celestron 8SE. So you might wonder, like, why do I need to buy this telescope, right? So one of the things that, there are several reasons why you should buy a Celestron 8SE or Celestron 6SE kind of telescopes. But I think there is one reason why you may need to think about this telescope, right? So if you are new to telescopes and if you are trying to learn, I think this is probably some information that I talk about here may be redundant. You may already know that information, but you might learn a little bit anyway. Okay, so now this Celestron 8SE is basically a 2000 approximately 2200 millimeter size, right? And basically the focal length of this telescope is f10. Okay, focal size is f10. So what that means is you are actually zooming into the sky and you are magnifying it at that level, right? Now, that is one main reason why you may need to look at Celestron telescope, Celestron 8SE telescope, is because you can see objects really close. Okay, I'll show you what that means by comparing and contrasting what it meant by really close. But a 2000 millimeter gives you a very close magnification of the objects that you wanted to see in the sky. So if you are trying to do like visual, use the visual back, put an eyepiece, look at maybe moon, look at a planet, or look at some star clusters, look at anything that you wanted to look closer, I think there is nothing that will beat beyond this telescope, right? But there are other reasons why you may need to look at this one. Okay, notice basically this is your telescope right now, and I'm looking at f10, right? What does it mean? So if you go to Astronomy Dot Tools, this is the website, Astronomy Dot Tools. If you go to this website, you will see an option basically to go to field of view. Okay, so this field of view essentially is a calculator. Let me show you how this calculator is going to work. So once you go to the field of view page, you can choose an object. Let us say an example. Okay, I wanted to see M81. Okay, so let's select M81, which is Bode's galaxy, or so Bode's galaxy. That's what you're trying to look at it. And let us say you're using the Celestron 8SE, right, or 6SE, one of them, right? So once you do that, this website gives you your focal length is 2000 millimeters. Your aperture is 203 mm. You're not using any eyepiece, leave that for now, custom eyepiece, whatever. Focal length is 28 and your field of view is 56 degrees, right? These are the defaults. And you're not using any Barlow, right? So what it is telling you is the focal ratio is f10. What does it mean? It's focal length by or divided by the aperture, right? 2032 divided by the aperture, which is 203, gives you a f ratio or focal ratio of f10, right? What does it mean in the camera language? Means your magnification is 72x. That's what you're getting when you're buying Celestron 8SE, right? You could play around with these ones, but leave like the way it is. And let's scroll down a little bit, right? What is that we are trying to look for? Click on add to view, right? The moment you do that, it puts a big red circle and say, if you look at M81, when you take a picture or when you look through your eyepiece, here is how the board's galaxy is going to look like. If you don't do any customizations, meaning like get a different kind of equipment, whatever, if you just buy off the shelf Celestron 8SE, you wanted to look at the board's galaxy M81, here is how it is going to look like. That's what it is telling you, right? Now, let us say, now you wanted to see not the board's galaxy, okay? Maybe you wanted to change your, deep sky object to something else, okay? Take an example that you wanted to see, let us say, let's pick something, right? Let's pick M51, okay? Whirlpool Galaxy, right? So let's say that's the one that you wanted to see, and now you don't want to, see that the image. It is showing that, hey, here is how a Whirlpool Galaxy M51 is going to look like, right? It's quite beautiful, and you really love it, right? You say, this is the perfect telescope I should buy. Let's go ahead, right? I mean, that's why you got what you got, right? Now, when you go down, let us say to, no, I wanted to see something else, right? Let us say you wanted to see M31, which is the Andromeda Galaxy, right? And if you wanted to see that in your eyepiece, look at what happened. Your field of view is so tiny compared to the galaxy itself. The galaxy is so huge, and you can't fit the entire thing when you are particularly imaging more than an eyepiece. When you are taking a picture of it, your Celestron 8SE won't really take a picture of the entire galaxy. It's actually going to go too close to it. Now you can't really see anything out of it. So why is that, right? I mean, why is where we are? In order to go out, not closer, right? Let's say if you are magnifying it, like, if you use your cell phone and you wanted to make anything bigger, you zoom in, you wanted to come out, zoom out, right? So if you are trying to zoom in, your F ratio is higher, okay? This F ratio that you are looking at is higher, means you are zooming in. If it is smaller, if this F ratio is smaller, then you are coming out and zooming out, right? How do we reduce the focal ratio of your Celestron 8SE? Well, let's see. Now, Celestron sells a small item like this, is called focal reducer. Okay, you can see the model number and you can see the Celestron, right? So the focal reducer, and then it says that if you see closer, right, you see that it is saying focal reducer is F63, right, F6.3. It is a focal reducer and a corrector, and it's basically saying that it is F63. What does it mean for us, right? For me, at least initially, the focal reducer name itself was counterintuitive. I thought I'm trying to buy a telescope, to see objects really, really close. Why do I need a reducer? I need probably, like an enhancer, not reducer. I don't want to make it smaller. I wanted to make it bigger. And I wanted to see, magnified images, right? So the moment I saw the field of view and my galaxy, and it is so close by, and I can't really, make out the whole picture, I figured out that by having a focal reducer, right, I probably can zoom out and I can see the entire object, right? So when I'm in f10, I'm like this. But when I'm in f6.3, I'm going away from it. Now, there is a difference between f10 looking closer and f6.3 looking further away, besides the increasing the field of view. What it is if you notice, your Celestron 8SC is a light bucket, right? It's basically a huge light bucket, and it is collecting light. All it does is collecting light. Now, the amount of light that the Celestron 8SC is collecting is the same, right? That's very important. Is the same amount of light no matter whether you are choosing focal ratio of f10 or f6.3, right? In case of f10, you are looking at the object that is closer, right? It's the same amount of light. Whereas when you are looking at f6.3, it's the same amount of light, but you are looking at further away. So you don't lose anything. You are collecting the same amount of light photons through your light bucket, which is the Celestron 8SC, but you are looking at a little bit bigger image. So I thought originally it was looking further away is not really what I wanted to do. That makes no sense, and I felt a cheaper telescope would do it anyway. And if I look at through my eyes, I can see much further away anyway. What's the big deal in reducing it? That's not the point. The point is the amount of light it collected is worth f10, right? It's as close as this one. But just for your reference of where this object is, you are zooming it out and seeing where the object is. So if you have a good enough camera that can capture all the light photons that are out there that you are seeing in the f6.3, the new field of view, you pretty much can zoom in and see the object again with the same level of detail that you would have seen in your eyepiece as f10. I think you're getting that point. Now let's go back to our favorite website, which is Astronomy Dot Tools, and see what happens when we change certain things. We are still looking at the same M31. We are still using the 8SE, the same focal length, same aperture, the field of view, nothing changed, right? All we are doing is we are not using the Barlow magnifies it, but we are using a reducer, right? So we are using something like a 0.63x reducer, right? So when we say that, and when we go into the add to view, right, and see what happens now. Now you see that your red is f10, right? Whereas your yellow, which is the new one now, the field of view, is giving you a little bit wider galaxy size so that you can see it better, right? Using the f6.3. Well, you might ask me now, like, what the heck? I didn't get the whole deal. I'm only seeing, well, a piece of it, right? I mean, you could jokingly think that I might use maybe two focal reducers, like, one put it on top of the other one, and I could get a better, zoom out and see the whole thing rather than zooming in like this, right? So, a stack and add one more focal reducer gives you a better zoom out view. That is not really the answer there. The answer is not that simple. It actually gives a very kind of not really good view technically. I mean, basically that's not the way the way you need to look at it. So we need to actually zoom out a little bit further out to make sure that we can see the entire galaxy. How do we do that? Yeah, before I go too far, I just wanted to make sure How do I use my focal reducer? Well, before I go to the next topic, basically all you have to do is take your visual back and the star diagonal out, and once you take it out, you need to put the focal reducer here, right? I don't want to drop it. It has a very powerful lens, so don't want to touch it. You screw this in the back, and then basically now you got your eyepiece and the field, the visual back, and all you have to do is install it, right? Then you are good to go, right? Let me give it a shot properly. So it's taking a little while. I'll try to, yeah. So anyway, so this is your installation of your focal reducer f6.3, right? So the next one that we're talking about is how do we get to a little bit more zoomed out view, like further away, right? I wanted to see that far, not closer, right? So now, here is what is going to help you. This is a piece of equipment that was made by a third-party source, not Celestron, but Celestron's other companies. It's called Starizona. I'll put the link out there. So this is basically called Hyperstar. Okay. Now these things are expensive. I mean, of course, you must have paid some amount for this Celestron, $800 or whatever. Now you are paying, $160, $200 for this focal reducer. Well, this one is a little bit more expensive if you wanted to use this option. This one is, I guess, close to $800. So if you get this one, right, what it will do is it will reduce the focal length way too small. Let's see how that works. So here is Starizona website. It's like Arizona, but Starizona, right? I can put the link out there. So for the Celestron 8 SE, they made a custom product. This is the one that you guys looked at it. It has a cap on it. So basically, you see the price, right? These are all quite pricey, but I mean, if this is what you want to get into, that's what you get. So anyway, the focal ratio is f2.1. Okay. The focal length is f425 mm, right? So if you go back into Astronomy Tools website, and if you say, I wanted to reduce my settings, easiest way to plug in is I'm taking the 425 mm and as my focal length, right? And then basically I'm going to leave the aperture. So basically see what happened here. It actually reduced the focal ratio to 2.09, right? Your magnification is only 15x. Okay. Now, if I add that to the view, look at what happens. So basically, when you see that image, now we are looking at 3 images. That green color is your hyperstar, the third item, which is I guess I mean the field of view these guys are saying is f2.1, and when you actually calculate it, it is actually f2.09, kind of the same thing. Anyway, I mean, you got the idea. So basically, if you want to zoom out this much, right, and you wanted to see, not just Andromeda galaxy like M31, but you also wanted to put M110 as well, you could picture that. I mean, you could picture neighboring galaxies and you could get pretty much, what you need. So you can zoom out from the f10 to f6.3 to f2.1 using the same telescope, right? That was the reason why I was saying one of the reasons why you should buy an 8SC telescope is because you could technically get 3 telescopes in one telescope, right? Well, the price is different though. Like you get $800 worth, now $1,000, which is $200 focal reducer. Now another 800 got added. So technically you are at like close to 1900 or 1800 price. You could get 3 different telescopes if you want to. This telescope of f2.1, you could get it a little cheaper, but not with this fast optics. We'll discuss that in a minute. Okay, so let's see how to install the Hyperstar. Now, this is the front of the telescope, right? Not the back, right? So basically you take, of course, the lens cap off, right? Now you are looking at the lens itself, right? So let me put it a little bit to the side so that you get an idea of what you are looking at. So this is the lens itself. You don't want to touch any of this, right? We know that already. You may need to clean the dust and all with all the right equipment. Now, the one thing that you will notice here is it has something. Let me zoom in a little bit, and probably you will make out. There is a logo, and there is a thing that it says F star ready, right? Your Celestron 6SE or 8SE should say that. If your telescope is not saying F star ready, I don't think you can do this. I mean, you need to call Star Arizona and see what choices you have. But anyway, but if that is saying that, right, then basically what that means to you is technically you can take this off. Make sure the telescope is flat, like the way I'm showing right now. It is not like, upside down or any other way. So you wanted to keep it fairly vertical. Then basically, horizontal. And then basically, you take this little ring off, right? This comes off pretty easily. Usually it is not tight, right? Once you take this ring off, I don't want to drop the ring there, okay? This ring comes out, okay? Now, the next item that we are looking at is this one. This is the one that is supposed to go in there, right? The Hyperstar. Well, it doesn't go like that, okay? What it will do is you may need to take your Hyperstar. Below the Hyperstar, they gave you this little cap kind of thing, right? If you unscrew that, right, it's kind of like a placeholder, you can call it actually, and there's a lens here. So, so this is just a cup and a placeholder, and it has a little tiny little notch there. See that? The little thing here. So what you need to do is slowly take this off, right? You see that? You take the telescope thing off. So basically, if you notice, this one is like reflecting the light, right? So that's how the SCTs work. Like basically they collect the light, they reflect the light, even though the telescopes are smaller, because they are doing that thing, even though your telescope is not really a long tube, you are getting the benefit of a long tube by having this kind of a reflection mirrors. So now you can take this one and technically you can put this inside this little box, right? And you can put the cap like the back as if it is plugged into your telescope. So this is now safe, right? You can secure that in a nice box. Okay, now this is where it comes in. This one will go right here on top of your other other telescope. It goes like this. I mean, if you can see it well, and basically you screw this. Don't screw this tight, just go to the end, that is the last thread, right? And basically thread up to that point and leave it, because a lot of people complain, I heard on the videos, that once if you screw it tight, you're going to like remove the entire plate, right? So you just wanted to go to a point where there is no more threads and you stop. You don't want to go any further than that, right? Now, how do you don't use normally eyepiece here. This is basically for you to image, right? Here is where you attach your, camera, whether it is DSLR. I mean, not preferred. DSLR is not a preferred choice. They ask you to use like a CMOS camera. In my case, I'm using the ZWO ASI 1600 or 071 or whatever. I can plug that in here and then basically, take a picture with that one. Gives you a better field of view. Now, the one thing that I was trying to tell you a minute ago was the following, right? So why f2, even though you're looking at wider field of view, why can't you just go buy another telescope and just use that in place of Hyperstar, right? Well, one is convenience. You can use the same telescope for all that. That's what I was sold on. I mean, there are many disadvantages of using Hyperstar too. So don't think everything is hunky-dory, let's go get one of these, right? But anyway, I mean, keeping all other points aside, the main reason why you are buying the F2 Hyperstar is you can use multi-purpose, right? The same telescope now gives you F2 imaging, right? Focal. What does it mean, F2 imaging, right? What does it mean to me? If I have a telescope, right, that gives me a wider field of view, and if I'm looking at that object and take a picture of that object, that's what you get, right? What this is doing is this telescope is capable of magnifying it to f10, right? So meaning you can go so close to the object. By doing this activity, you are collecting the same f10 light, but you are in fact taking only a portion of the light, you are actually magnifying it and looking at a wider field of view, right? So if you can collect all the light photons in f2 as if you are collecting as f10, your imaging is much faster. There is a technical spec there that says it's 25 or 23 times faster, but anyway, I'm still playing with it. I'm fairly new. I'm not a super duper expert in this area, but it's kind of fast, okay? But I'll prove it and see if it is really the 23 times faster. We'll figure it out. But anyway, the point is it's faster because it's collecting f10 light, but you're collecting it much faster and putting it out there. And if your camera is good enough, that can record all this stuff with all the necessary data, then basically if you zoom in, you can even get a smaller object with the same crispiness, or zoom out and you get the entire galaxy or whatever. That was the point of this one, right? Well, I hope you guys learned something from this video on why to buy the Celestron 8SE for 3 different focal lengths, f10, f6.3 and f2.1. Okay, thanks for watching. Please subscribe to the channel below. Thank you very much.